video, I'm going to introduce an idea called an antiderivative. So in physics, if you can imagine, if the velocity of an object is known, we might be interested in determining the position of the object at a certain time. This means that really we know the derivative, which is the velocity function, and we essentially want to work backwards to determine the original position function. And this idea of working backwards from a derivative back to the original function is called an antiderivative. So for right now, the notation that we're going to use for an antiderivative is a capital F of x. And so we'll say that capital F of x, or big F of x, is the antiderivative of a function, little f of x, as long as when you take the derivative of that function, you get little f of x. So this is like saying if you take the derivative of a position function, you would get a velocity function. So we're going to be working backwards essentially. So let's think graphically just for a second. Suppose you've got a function f of x equals 3x squared, and we're interested in finding the antiderivative of this function. So if we were finding the derivative, we know we'd use our power rule. We would subtract 1 from our exponent. But because we're working backwards, essentially, we're thinking that we want to add 1 to the exponent. So where would this function come from? F of x equals 3x squared. If this was the derivative, then what was the original function? That's called the antiderivative. And you might be thinking that one of the antiderivatives could have been, let's say, just x cubed. So we want to check that. Again, to check if this was correct, we would take the derivative. The derivative of x cubed is 3x squared. And sure enough, that's exactly the function that we started with. So capital F of x equals x cubed, that's an antiderivative. But the question is that the only antiderivative? Now let's think graphically. If we were to graph x cubed, and this is just going to be a really rough graph, a loose graph, I'm not even going to include any tick marks, we know that x cubed is just a nice cubic function like so. Now, is that the only antiderivative? Well, what if we were to add a constant? So what if I said the antiderivative was x cubed plus 2, let's say? If I were to check that and compute the derivative of that function, the derivative of x cubed would be 3x squared, and the derivative of 2 would be 0. So this is another antiderivative. X cubed plus 2 would work as well. So think graphically for a second. What happens when we add 2 to our function? That's going to be just a vertical shift, up 2. So I'll have the same shape, but my function now has been shifted up 2. This is the graph of x cubed plus 2. So again, is this the only other antiderivative? Are there only 2 or are there others? Well, you're probably getting the idea now that I could really add or subtract any constant value. Let's subtract 1 here. How about x cubed minus 4? Again, if you were to check this by taking the derivative, you will find the derivative is 3x squared. So this is yet another antiderivative for the original function that we were given. And graphically, this would be a cubic function shifted down 4. Same shape, but the function is shifted down this time. So the idea here is that you have an infinite number of possibilities for the antiderivative. So we don't just write one of these antiderivatives, but rather we call it the general antiderivative. So in this case, the general antiderivative for f of x equals 3x squared will be big F of x is equal to x cubed plus any constant. So we'll just use c to represent our constant. And this is called the general antiderivative. And this is what we're going to be working on in this section, not finding a specific antiderivative right now, but rather a general antiderivative. And this general antiderivative represents a family of functions. This family of functions is graphed to the left. You can see it's a bunch of functions that are being shifted up or down. So the general antiderivative represents a family of functions. And that family of functions is what we're going to work on finding next.